Okay, so just okay. So in this sessions, okay, in this elements modern physics. Okay, so okay, so in these sessions we will try to solve some of the problems, okay, related to Lagrangian, related to Hamiltonian, and also related to relativity. Whatever you have, I think you have seen those assignments. I think 4 to 5 questions. Okay, we'll try to address it here today. And any questions if you have, you can always send it to me also. I have no problem. Okay, you can always send it to me to this email. Let me just write my email ID. Okay, my email ID is, sorry, lucky22 at the rate of iisertvm dot ac dot in. Okay, you can always share any questions if you feel that you have any questions anytime. Okay, you can always share any questions. Then in the next sessions or in the next tutorial we can address those questions. Okay, so before we move forward to solve those problems, okay, I will also give you some formulas here and there such that you will be familiar, because from your lectures it will be like 3 to 4 hours lectures in a week time, so you might not be able to remember all the formulas that we need to solve a problem. So along the way I will also give you some problems or some formulas here and there in which it will be easy for you. Okay, so so before we start solving the problems, I hope you have seen the assignments. Okay, let me just go through the assignments. So there are 5 questions. Okay, and the first questions is related to your whatever you have already been doing related to your BSc or related to your higher standards. Okay, this does not involve that much complicated complicated solutions. And in the second assignments, these involve that we have to write the Lagrangian, and we also have to solve the equation of motion. The third problems oh, sorry, this is the second, the previous one is the third. The second problem is related how do we derive the Hamiltonian's equation, and also how to describe the details of the motion. And the last 2 problems is related to your relativity. Okay, so before we solve those problems, let me just, okay, go ahead and do few things. Okay, that means I would rather say to just recap. Okay, to just recap. Okay, you might have already know about this. Okay, you have might already known about this, but let me just recap few things such that it will be clear to you before we solve the problems. Okay, the first one is degrees of freedom. So what is degrees of freedom actually? So degrees of freedom is in fact minimum number of independent motion. Okay, what I mean by this is that, suppose I'll give you an example. Suppose you have 3 axes. Okay, you have 3 axes, and that is given by, let's say this is your x-axis, this is your y-axis, and this is your z-axis. Okay, so suppose I have one particle here, and this particle can move anywhere between the x direction, the y direction, and the z direction. So how many number of coordinates, or how many number of coordinates you want to describe this particle? Okay, that means it can move in x direction, it can move in y direction, and it can move in the z direction. So the degrees of freedom in this case will be equal to 3, because it can move in all the direction. It can move in x direction, it can move in y direction, it can move in z direction. So for me to describe this particle point P here, I need to describe the x coordinate, I need to describe along the y coordinates, and also I need to describe along the z coordinates. Okay, so in the x comma y comma z. Okay, now suppose if there are n particles in 3 dimension, then degrees of freedom will be equal to 3 into the number of particles. Okay, another things, okay, I'll just put this in a box. And the last, if there are k constraints, then degrees of freedom will be 3n minus k. Okay, I'll give you an example what I mean by constraint. Constraint means you put one equation which relate one coordinates to the other. Okay, let me give you an example if what I mean by constraints. So let's say you said that, okay, let's say particle moving in x y plane, example. Okay, so the degrees of freedom will be what? Initially it will be 3, but because you have clearly mentioned that it's moving in the xy plane, that means automatically you know that z equal to 0, right? You already know now z equal to 0. So now instead of your 3 degrees of freedom will be equal, there is one constraint, so 3, that's one particle, 3 into 1 minus 1, which is equal to 2. So you see, if you restrict the motion, or if you want to restrict the motion of the systems, then the degrees of freedom also will reduce. So now this z equal to 0 is actually the constraint that you impose. You said that, okay, the particle move in the xy plane, not in the z direction. So in that case, your degrees of freedom will reduce by 1. From 3, it reduced to 2. Okay. Another example, I would say, okay, another example is a simple pendulum. Simple example. Simple pendulum, okay, in xy plane. Okay, again in xy plane. Then what will happen to your equation of constraint? Okay, equation of constraint, you have z equal to 0. Okay, let me draw first a diagram, that will be easier. Suppose you have this is x direction, and suppose you have this y direction, and let's say suppose this is your pendulum, okay, and this of length L. Okay, first constraint, equation of constraint will be z equal to 0. Okay, the second constraint will be, you know, this length L is fixed, correct? So that will be x square minus plus y square is equal to length square. Okay, that means you have expressed your x and y values in terms of some constants. Okay, so now the degrees of freedom will be equal to what? Will be equal to 3 into 1 minus, there are 2 constant equations, so 3 minus. That means you need only 1 degrees of freedom to express the system. That means if you know the value of x, you automatically know the value of y through this equation. Let's say this is equation 1 and this is equation 2. If you know the value of x, then automatically you know the value of y by using this equation L square minus of x square. So this is a simplest degrees of length of freedom. Now, before we solve the problems, there is another concept called Lagrangian. Okay, there's a Lagrangian concepts. Okay, after this, then we will solve the problems. Okay, so when I say Lagrangian, what is in fact Lagrangian? Okay, so we all know, starting from from Newtonian mechanics. Right, that F is equal to ma. Okay, that you know. But then what happens what happens to the Lagrangian? Why do we need Lagrangian? So see, if you want to solve like a more complex systems, okay, Lagrangian is another way of solving the equation of motion. They are not that different. Okay, so the main idea is to solve the equation of motion, or to solve how does a systems evolves. Okay, so that is the main thing. But then there are different ways in which we can try to solve the problems. Okay, so instead of solving this equation, whatever we have known, let's also form another way to solve the problems. Okay, so let me just give you an idea of how do we get from f is equal to ma to your Lagrangian. Okay, why do we need this problem? Okay, you will see why is it required. Okay, so example, like consider n particles in a conservative force field. Okay, so what happened? Total kinetic energy of the system will be T equal to summation of half of m I x I square, and n is equal to 1 to m. Okay, so if for each particle in one dimension, then what happens? Degrees of freedom m, okay, degrees of freedom m is equal to n. For 3D, then sorry, for 3D, then your degrees of freedom will be equal to 3n. Okay, because there is no constraint. Now, what happens? Del t by del of xi, if you differentiate del t divided by del of xi dot, if you go del t divided by xi dot, that means you differentiate this equation 1, del t by del of xi dot will be equal to what? Will be equal to 2 by 2 mi x, oh sorry, this is xi dot square, sorry, xi dot, which will be equal to m of x dot. This mx dot is equal to what? X dot is in fact m dx by dt, which is in fact what? M into the velocity, which is in fact momentum. Okay, then what happens if we do d by dt of this equation? D by dt of del t dot by del of xi dot is in fact what? Dp by dt, isn't it? D by dt of m of x dot, which will be equal to m of x double dot, is equal to force. Now what happens is that now is this equation, you know, right? This equation is in fact what? From the Newton's law, F is equal to m of x double dot. Now for conservative force field, okay, we can write what? F of I, that means this one, F of I, F m x I double dot, F of I is equal to minus of del V by del of xi, and F of I is equal to dpi by dt. So what happens is that now we can write what? D by dt of del t dot by del of x of I dot. Okay, instead of the force, you can write minus of del v by del of xi. Okay, I will name this maybe some equation 2. Okay, then again del t by del of xi equal to 0 for conservative, and also del v by del of x of I dot will be equal to 0. So then if we add this equation here from equation 2, we can do in this way: d by dt, okay, of del divided by del of x of I dot t minus v, since del v by del of x I dot is also equal to 0, so there is no harm in it, minus of del by del of xi t minus v equal to 0. So we can write the main equation, this one, as d by dt of del L divided by del of xi dot minus of del L divided by del of xi equal to 0. So this is what we call as the Lagrangian equation. Here L is equal to T minus V. Okay, I'll name this as equation star. So the idea is that, we can just go from Newton's law of motion, F is equal to ma, and we can write the Lagrangian equation of motion. Why this Lagrangian equation is very, very important is because we can introduce what we call as a generalized coordinate. I think in the lecture it must have been there, generalized coordinates. That means instead of xi, we can represent with a general coordinates in the form d by dt of del L divided by del qi dot minus of del L divided by del qi equal to 0. Now this qi is in fact generalized coordinate. Okay, so example, if qi equal to x, then what happens? Qi dot will be x dot. X dot is what? Will be in turn velocity. So if qi is the position, then qi dot is in fact velocity. Okay, so now instead of representing xi, yi or x, y, z coordinates, we represent in a more generalized coordinates by qi. Okay, and this equation helps to solve a much more complex problems. Okay, so now we have seen generalized coordinates. We also have seen degrees of freedom is the minimum number of independent motion. We also have seen that you usually when you solve your Lagrangian is usually in terms of generalized coordinates qi and qi dot, right? Qi and qi dot. Now we will solve your first two problems. Okay, so now let us go to the first two problems. Okay, so here, okay, what is happening here? Okay, so just a second, please. Yeah. So here, according to this question, I think you have seen these questions from the assignment, okay, PDF. What happens is that you consider a mass m. Okay, at this point, the first question does not involve with Lagrangian at all. It's simply, simply an equation of motion problems. Okay, so what consider a mass m to be fixed to the end of the rod. Okay, as you see here, a mass m is here, and consider is fixed to the rod of the length L. Okay, so in other words, I would rather say, I will redraw it again. So what happens is that you are connecting a mass m, okay, to one end, okay, and then this one end of rod is rotated with an angular frequency omega. Okay, this is m. Now this makes at an angle alpha. Okay, and this is of length L. Now the question is, what happens is that m is fixed to the end of the length of m to be fixed to the end of a rod of length L which has negligible mass and is permitted to swing from the end of rod that rotates at an angular frequency omega, as shown in the figure. The mass moves with steady speed in a circular path. So that means this mass here is trying to move in a circular path, okay, at a constant radius r. The question is, find the angle, okay, alpha, that the rod makes with the vertical at equilibrium. Okay, so how do we solve this problem? Okay, we can start using the vertical. So we can start using vertical motion. Okay, what happens in the vertical motion? Okay, so if you look at it, what will happen? There will be mg force, okay, acting down, and if there is a thread, there will also be a tension, okay, in the opposite direction. And if we extend it into the x and y direction, okay, then this will be what? This will be t cos alpha, and in the negative direction it will be t sine of alpha. Okay, so if you want to be in equilibrium, what will happen? T cos of alpha, that means this term here, let me just write here, t cos alpha here should be equal to mg. Sorry. Should be equal to mass into the acceleration rate. That is one equation. Okay, so the vertical motion is that your t cos alpha, t is the tension, okay, t cos of alpha, which is in the upward force, should be equal to your mg, which is the downward force, right, when in the vertical motion for an equilibrium state. Now what happens? Okay, let me just write this as equation 1. Now what happens in the horizontal direction? Okay, now there is a horizontal direction as well. So what happens in the horizontal direction? First of all, you have a t sine alpha, okay, a component of the tension which is in the negative direction, and also now the rod is trying to move in a circular path. So when you move in a circular path, what will happen? Angular acceleration you have an angular acceleration which is equal to minus of omega square r, omega square r. Okay, and what else? You also have your T sine alpha force. That means T sine of alpha should be equal to minus of m omega square r. Okay, so this is also one thing. Now since T sine alpha pointed in the negative direction, so you can also add a negative direction here. Okay, now you have two equations, which is the vertical motion and also the horizontal direction motion. Okay, now these two has to be equated together. Okay, so one thing that you can do is that you can evaluate this r term here, that is the radius. So r is equal to what? If you look at the equation, this is actually r, so r is actually L sine alpha. Okay, because this is radius, so this will be L, this will be radius, so r will be L sine alpha. Okay, so r will be L sine alpha. So let me name it as equation 3. So now you have what? Vertical motion, you have horizontal direction motion, and you also have the r term in terms of alpha. So what you can do is that, so you can take the equation 2. So from equation 2, okay, the negative sign and negative sign is already cancelled. So you have T sine alpha equal to m omega square, and instead of r you can write L sine of alpha. Okay, so sine of alpha on the right and sine of alpha on the left can be cancelled. So T is equal to mass omega square L. Okay, so now this is equation 4. So if you look at it now, remember that we need to equate equation 1 and equation 2. Okay, now r is in terms of alpha, r is in terms of length as well as in terms of alpha, and we have equated, we get the tension to be equal to m omega square L. Now from equation 1, what is equation 1? Equation is T cos alpha is equal to mg. T cos alpha equal to mg. So what you need to do is that instead of T you can write m omega square L cos alpha equal to mg, and then mass and mass can be get cancelled. So cos of alpha is equal to g by omega square L, and finally you have alpha is equal to cos inverse g by omega square L. Okay, so this is your final result. So what does it mean? It means, you start on the two directions. One is the vertical direction and one is the horizontal direction. So you write the equation for vertical motion, and you also write for the equation for your horizontal direction, and then you equate them to one another. Okay, so then you find out what is the value of alpha in which this mass is moving in a circular path. That's the question. Find the angle at which the rod makes with the vertical equilibrium. Yeah, the mass moves with this constant in a circular path at a constant radius. Okay, now you have to find out the value of alpha such that the system is in equilibrium. So now you get the value of alpha in such a way that there is a relation between your alpha as well as your omega. Okay, so in this problem, okay, there is no involvement of like your Lagrangian, which we have just discussed. Okay, it's simply your vertical motion as well as your horizontal motion. Okay. Now if we look at these problems number 2. Okay, so in the problems number 2, what is happening is that, sorry, not problem number 2. Problem number 2 I will do in the next after the equation number 3. Okay, this is the problem number 3 because it's more related to what's the first thing that we have just discussed. Okay, so the question is, a bead of mass m slides without a friction on a parabolic wire z equal to ax square. So you see, this is already given to you. The figure is already given to you. This is already given to you, the figure. Okay, so this is your mass m actually. Okay, under gravity. Now the wire is kept vertical as shown in the figure. So what will happen now? You have to find out what is the as I've just said, the degrees of freedom, and you have to find the Lagrangian function, and you have to find the equation of motion. Okay, so this is the thing that we have just discussed, right? That how do you write the degrees of freedom, and then um, after you have written the degrees of freedom, then you have to write the Lagrangian function and find the use of the problems. Okay, so let me write the solution. So if we look at these problems, the first question that comes, the first question that we should ask is there any constraint? Because as I have just said, the general degrees of freedom will be equal to what? 3n minus k. Okay, 3n minus k. So where n is the number of particles and k is a number of constraint equation. So now if you look at it, what will happen? Since it is in the x and z direction, automatically you have y equal to 0. Okay, this is one constant equation because there is nothing in the y direction. And the second is you also have given the equation, it's already given the equation, z is equal to ax square. So this is also another constant equation, ax square. That means this is equation 1 and this is equation 2. Looking at this, you have two constraint equations. So that means the degrees of freedom in this system is equal to 3 into 1 minus 2, which is equal to only 1. Okay, that means if you are able to solve one coordinates, you are able to solve the whole complete systems. That means if I get the value of z, let's see, if I know the value of z, then automatically I know the value of x also because z is related by this equation. Or if I know the value of x, then I automatically know the value of z also, since again y equal to 0. So the degrees of freedom for the solution number 1 is 1. Okay, now the solution number of equation b. Okay, so we have to write the Lagrangian motion. Okay, now how do we write out the Lagrangian motion? So Lagrangian is equal to T minus U, which is the potential energy. Correct. Now T is what? T is your kinetic energy and U is your potential energy. So now we have to write first your kinetic energy and your potential energy. So T is equal to what? Half of m. Since there are only in the x and z direction, you have x dot square plus z dot square, right? Because y is equal to 0. So you have x direction and z direction, which is equal to what? Half m. Now x dot square remain the same. And what about z dot square? Z, you already know here, z is equal to ax square. So I can replace the value of z in the form of x. So which is equal to z dot is equal to what? 2ax and x dot. Then z dot square will be equal to 4a square x square x dot square. Okay, now you see your kinetic energy. Now initially there are x and z that you need to solve. There are two variables here, x and z, right, or two coordinates. But now you have only one, x and x. Why? It's because I have replaced the value of z in terms of x. So this is your kinetic energy, and the potential energy is equal to what? Potential energy is simply mg z, right? Because your mass m is at the height h or height z. Okay, so it's simply mg z. That is your potential energy. Sorry, this should be small m actually. It should be mg z. Again, now your z can be simply replace mg, and z is actually a x square. Okay, so now you know your kinetic energy and you also know your potential energy. So what is your Lagrangian? Lagrangian is simply T minus of U, as we have just discussed. So which will be equal to half of m. Take this equation, half of m, we get half of m, we get x dot square plus 4ax square, 4a square x square x dot square minus m g a x square. This is your Lagrangian. Okay, so if you want to solve the Lagrangian, what you need to solve T minus of U, which is the kinetic energy minus of potential energy. That I have already given you the formula just at the beginning of this class. How do we get Lagrangian? Is simply kinetic energy T, which is and minus your potential energy. So now the second problem is done, right? T minus U is done. Now the third is but is the third problem is find the equation of motion, right? So find the equation of motion. What you need to do is that what is the equation of motion? In the first thing I have just given d by dt of del L by del Q dot minus of del L by del Q equal to 0. But here Qi is in fact the generalized coordinate. So what is the coordinates that we are working here is x. Okay, Q is just a generalized coordinates. Okay, it can be x, it can be y, it can be z. Okay, but here since there is only 1 degree of freedom, we will be working only on x. Okay, so now the equation of motion will become d by dt, okay, of del L divided by del of x dot minus of del L divided by del x equal to 0. So now you have just to take the derivative of this. Okay, so if I want to take the derivative of this, first let's start with del L divided by del of x dot. What happened del L by del x? Because we need to solve these problems. Del L by del of x dot, del L by del x, and take the derivative again. Okay, then you will get the total solution. So del L divided by del of x dot. Let me just make this equation a little easier for you. Half m, okay, and I can take common x dot square because there is x dot square and x dot square here. I can take common 1 plus 4a square x square and x dot square minus of mg a x square. Okay, so if you take del L by del of x dot, that means you have to differentiate this with respect to x dot. Okay, and if you take del L by del x, then you have to differentiate again this equation with respect to x. Okay, so del L by del of x dot is equal to what? Since in this second term there is no x dot, so del L by del of x, this term anyway will go to 0. That means you have only the first term here. So you will have half m, okay, 1 plus 4a square x square 2 into x dot. Right? So 2 and 2 will get cancelled, so you will have only m x dot 1 plus 4a square x square. Okay, so the first term we have done, del L by del of x dot. Now we need to find the second term, del L by del x. So del L by del x, again there will be two terms. Now why is because if you look carefully here, the Lagrangian, you have x here and you also have x here. So if you take the derivative, you will get half m, okay, x a square 8a square and x dot square x minus 2mg ax, okay, and finally you will get 4m a square x dot square x minus 2mg ax. Okay, this is just the take the derivative of del L by del x and del L by del of x dot, and then let me name this as equation star. Then you can put, and this is equation, let's say this is equation 1 and this is equation 2. So you put equation 1 and 2 in equation star. Then what happens? You can write, then you can write d by dt. Okay, so now del L divided by del of x dot, you can put this value here. You will have mx dot, isn't it? Mx dot and mx dot, and inside the bracket you will have 1 plus 4a square x square, okay, and and then minus of del L by del of x will be equal to minus half not minus half, will be equal to this equation number 2 minus of 4 m a square x dot square x, and then negative from here and negative from here, you will get positive, you will get 2 m g a x equal to 0. So you just need only to differentiate this equation now, and then you will get the equation of motion. So what happens, you will get mx double dot d by dt of mx dot will be mx double dot and 1 plus 4 of a square x square. Okay, and now you have to differentiate the second term mx dot. You will have d by dt of 1 will be equal to 0, so here will be equal to 2 from here, so you will get a square x and x dot. Okay, minus, then the second term will remain the same, 4m a square x dot square x plus 2m g a x equal to 0. Okay, so now this is done. You just need to rearrange and then it will be over. So you can write, what happens is that you can write m x dot now 1 plus 4 of a square x square. Okay, and these you can subtract because they are all of the same type. So you can write 8 minus 4, it will be 4, and you can take common m x dot square and x, and a square also should be there. Yeah, 4a square also should be there, and finally you get 2mgax. So this is in fact what your equation of motion. Okay, you can take common m, okay, and then everything will goes to 0. X double dot 1 plus 4a square x square, because there are all term here, mass plus 4a square x dot square x plus 2gax equal to 0. So this is what you call as the equation of motion. So if you look carefully in this problem, what you need to do is that first you need to solve the degrees of freedom, okay, and you find out what is the whether there are constraint equation or not. So yes, there are constraint, y equal to 0. That is automatically, because you know it moves, your particle is moved in the x and z direction, and the second, z is equal to a of x square. So you can express every terms in terms of x. From z you can represent in terms of x. Okay, so then you solve the problems degrees of freedom, and you find out the Lagrangian. Lagrangian is simply kinetic energy minus the potential energy, and you know the kinetic energy is half of mv square, but in terms of generalized coordinates you have to write half of m of x dot square plus of z dot square in 2 dimension. Then you also know the potential energy, which is in fact potential energy we can infer simply mgz, right? And also you represent z now in terms of x square. So this problem is reduced to 1 degrees of freedom. Why? Is because now from z you have you are working now only with x coordinates. Okay, then you write the Lagrangian and you solve the equation using this equation. Okay, equation star. Okay, this is what this problem number 2. So okay, so sir, x dot is simply the first derivative of x. Yes, correct. Yeah, x dot is simply the derivative of d by dt. So let me just, okay, maybe some slightly confusion. So x dot is d by dt of x. Okay, sorry. Okay, so then x double dot is d by dt of x dot. Okay, fine. So thank you for that. Okay, so so now so the first question and second question is done. Okay, so we first start from a simple Newtonian mechanics. Okay, simply vertical motion and in the vertical motion as well as a horizontal direction of motion. Then we move to the Lagrangian. Why Lagrangian? I have told you that there are problems in which you cannot easily solve with simply f is equal to ma that you have done before, right? So in fact, for a more complex problem like these problems, it's not easy to solve with f is equal to ma, but instead you can write in the form of a Lagrangian and you can easily solve the problems. Okay, that is one way. And we have also I have also shown you that how do you get simply from mx double dot, which is the force, in terms of the Lagrangian equation of motion. Okay, now I think the third problem that we are talking about now is another form. Okay, so if you look properly, maybe I can write it here, or maybe, okay, I can jump to the, sorry, let me do here. Okay, so here from Lagrangian, we are going to move to Hamiltonian. Right? And why is it so? Okay, why is it so? It's because, like, we start initially from Newton, then Newton mechanics, then we go to Lagrangian to solve the problems, and now we go to Newtonian mechanics. Why is it that so? It's because, in Lagrangian we are involved on the coordinates q and q dot, if you remember, right, qi and q dot. But here in Hamiltonian, you will also be able to analyze the conservation of energy. Okay, in Lagrangian, we have never talked about the energy term. Okay, but here in Hamiltonian formalism, you can write Hamiltonian formalism is in fact you are able to also analyze the energy term. That is why from Lagrangian you also move to Hamiltonian formalism. And in Hamiltonian you are working with coordinates q and momentum. Okay, in Lagrangian you are working with coordinates q and q dot, but in Hamiltonian you are writing the coordinates q and p, which is the moment. Okay, so again I will give you the formula before I solve the problem so that you will have an idea. So Hamiltonian is equal to, which is a function Hamiltonian, which is a function of q I pi and time t, is equal to summation of qi dot pi minus Lagrangian qi dot and time t. Okay, so that means you have expressed your Lagrangian, whatever you have done before, okay, in terms of your Hamiltonian using this equation. Okay, so just a second. Now, how do we really so how do we go from Lagrangian and to Hamiltonian? Simply, I will give you one example. Okay, simply very examples. So you have, let's say, you have the momentum pi is equal to del L divided by del qi dot, right? So sorry, have I described this equation? Oh, okay. So sorry. I have not. But maybe you might have seen in the lecture notes that from Lagrangian you can derive what is your momentum, which is equal to del L divided by del qi dot. Okay. Now example, let's say Lagrangian is equal to half of m of x dot square. This is simply half of m x dot square or half of m v square, which you know. Now your momentum p will be equal to del L divided by del of xi dot, right, which will be equal to 2 by 2 m of x dot, which is equal to simply m x dot. Now you can rewrite x dot is equal to p by m. So now if you look at the Lagrangian, now what happens is that L is equal half of m. Instead of x dot square, you can write p square by m square, or you get p square by 2m. So now your Lagrangian, which is in fact initially x dot, now you have expressed in terms of your momentum. This is one way to go. That is how you can easily solve the problems from Hamiltonian. How to solve the Hamiltonian given let's say Lagrangian is given to you. So suppose if a question is given like Lagrangian is given to you, then you have to solve the Hamiltonian. This is one approach. You have to convert your x dot, okay, into momentum. This is very, very important. You will see when you solve the next problem why your x dot is converted in terms of p and m. Okay, but the idea behind is that Hamiltonian helps you to also analyze your conservation of energy, because in Lagrangian we have not talked about your energy, but here in Hamiltonian you also be able to analyze the conservation of energy. Okay, and also one thing which also I think for you, just a general idea is that in Lagrangian you are dealing with second order differential equation, isn't it? If you look carefully, d by dt of del L divided by del of q dot minus of del L divided by del Qi equal to 0. See, this is a second order derivative, second order differential equation, right? But in Hamiltonian, what happens is that simply I'll rewrite it again. Hamiltonian H is equal to simply Qi dot P minus Lagrange, isn't it? So that means only this is your first order. Okay, so in second order, okay, there are problems in which it is, I mean, you can solve with the second order differential equation, but then for for complex problems you might want to solve with given that Hamilton is given to you, so it will be easy for you to solve knowing this is a first order differential equation. Okay, that is also one advantage of the Hamiltonian. Also, that is also one advantage. Now, so now let's look at the problems. Just a second. Let's look at the problems. Okay, but before looking at the problems, again I will give you one set of equations which is important. Okay, because we are going to do that again. So given Hamilton is given to you, q dot p minus Lagrangian, then again equation of motion. Okay, equation of motion. Okay, the same thing, like just like you have a talk about the Lagrangian. First you have to write the Lagrangian, then you have to write the equation of motion, right? And then you solve the equation. Then here also is the same thing. First you have to write the Hamiltonian, then you find the equation of motion, then you have to solve the equation. Okay, simple. First you describe the Lagrangian or Hamilton, then you write the equation of motion, then you solve it. Okay, so these are the same, but it's just like the formulas are different. Equation 1 is what? Qi dot is equal to del H by del Pi, comma, that is the Qi dot equation of motion. Then Pi dot is equal to minus of del H by del Qi. Okay, this is the second. And the third is del H by del T equal to minus of del L by del T. Okay, so these are the equation of motions from your Hamilton. Suppose you write the Hamiltonian, then you find out, then you write the equation of motion using these three formulas. Now, there is one more idea that Hamiltonian del H by del T equal to 0. If del H by del T equal to 0, then what happens? Then it means that H is conserved, right? H maybe or maybe not total energy. Okay, but it shows that your energy term is conserved. If del H by del T, if your Hamiltonian H does not change with time, then that means your H, which is an energy, remain conserved. So that is also one thing that we see here in Hamiltonian, that we usually solve the del H by del. If you want to show that okay whether energy is conserved or not, we have to find out dH by dt. Okay, and also this is one thing, and second thing is if a coordinate Qi is absent. This is also one important thing that usually comes in the problem. If Qi is absent, that means what happens? Pi dot, just from equation of motion, from equation number 2, let's say this is equation 1 and equation 2, and this is equation 3. So equation 2 will be Pi dot is equal to minus of del H by del Qi. Is it? Minus of del H by del Qi. So if Qi is absent, then automatically Pi dot will be equal to 0. If Pi dot equal to 0, that means d of Pi by dt equal to 0. So that means d by dt equal to 0. What does it imply? Implies your momentum Pi is equal to constant. Right? So this is also one important things that usually questions comes, that suppose if Qi is absent, then which quantity is conserved or which quantity is constant. Okay, so now if Qi is absent, then you call this Qi as a cyclic coordinate. Okay, so I will not give you like unnecessary formulas which is not there in the problems. Anyway, it's already there in the lectures, but I'm just giving you a recap of what are we going to use in the problems. Okay, suppose you have a Lagrangian, you write the equation of motion, and these are the two possible that in a question usually come, let's say if you have to find that the energy is conserved or not, and let's say if the coordinate qi is absent, then which quantity is constant, and finally we will be able to solve the problems. Okay, so now let's go to the problems. I think you remember now the Lagrangian. Let's go to the problems. Yeah, so now what happens is that now you have to look at this question. Consider a particle of mass m. So remember, a mass m is moving in 2 dimensions. Remember, in 2 dimensions, subjected to a force F is equal to minus of kx, ky. Okay. Considering x and y as generalized coordinates, now they have mentioned that x and y are generalized coordinates. Write down the Hamiltonian of the systems. That is the first question. See, you have to write down the Hamiltonian of the system, then derive Hamiltonian's equation, which I have just given you the Hamiltonian's equation, and solve them to describe the details of the motion. See exactly what I have given you just now. We have to write what is the Hamiltonian of the system, then we have to write the Hamilton's equation, then finally we solve them. Okay. So how do we solve the how do we get the Hamiltonian? Remember, Hamiltonian of the systems will be qi dot pi minus of m. So which means that now, since there are 2 coordinates, it means x dot px plus y dot py minus l. Okay, but I mean, this is just the general formula. Now we have to solve it. We have to find out what is very, very important is that we have to find out what is the Lagrangian, because Lagrangian here is not given. So you have to find out. So how do we find Lagrangian? Remember that L is equal to T minus U. That is kinetic energy minus the potential energy. So we have to solve these terms first. Now, so kinetic energy is easy anyway, right? Kinetic energy T, which is the kinetic energy, is simple half of m, and then inside bracket we get x dot square plus y dot square. This is easy because your particle is moving in xy plane, so you have a kinetic energy which is equal to half of m of x dot square plus y dot square in 2 dimensions. Now, what is U, which is your potential energy? So instead to find U, instead of U, they have given you the equation force equal to minus kxi cap plus ky j cap. Okay, instead of the potential energy is given in terms of your force. So how does force and potential energy are related? You use this formula, F is equal to minus of del U. I think you have seen this equation, could be in electrodynamics, right? Force is related to the potential energy as F is equal to minus of del U. I have just taken it from there. Okay. Now, what happens is that minus F is given as minus of k x I cap plus ky j cap, and minus, this is the gradient, which is equal to minus of del by del x of U, and it will be I direction, right, in 2 direction, minus del by del y of U in the j direction. Okay, so what I have done is that force I have equate with this equation, given equation, and I have just expressed your gradient of U in terms of minus of del by del x of U, and also in terms of y direction, right? So now what you need to do is that you can just equate one of them. So negative and negative sign will get cancelled, so you can get sorry, I think there is some issue here. Okay, yeah, fine. So so you equate I cap with I cap, that is x with x direction and z with z direction, or I mean sorry, y with y direction. So what do you get is that del U by del x, negative and negative sign anyway is getting cancelled, you get kx, and del U by del y is equal to minus of ky, right? So if you integrate on both sides, then what happens? U is equal to k of x square by 2, right? Integrate this equation plus the constant c1, and U, this is ux, and uy will be equal to minus of k, and integrate this one in terms of respect y by 2 plus of some constant c2. Since now if you put both of them together, then we get U is equal to, you take this 2, so k of x square by 2 minus of k of y squared by 2. Okay, you can neglect a constant because anyway they will not change the equation of motion. It's just a constant term. So you can write half k x square minus of y square. Okay, so see what you need to do. You can find the potential energy from the force using the formula F is equal to minus of del u. Simple as that. Then you equate what is ux and uy, and finally you will get u, which is equal to half k x square, k of x square minus of y square. Okay, so now you know the potential, energy, and also you know the kinetic energy. So you can write what Lagrangian will be simply half m x dot square plus y dot square minus half k, your potential energy, you get x square minus of y square. So your Lagrangian, now you know the Lagrangian. Using the formula now, this formula, equation 1, you can calculate what is your Hamiltonian. So what is Hamiltonian now? Hamiltonian will be equal to before I go to Hamiltonian, let me just calculate a little more. Okay, so that it will be easy. So I have mentioned to you that when you write your Hamiltonian is usually expressed in terms of x and momentum, right? In terms of x and px, that is called that is your x coordinate or your position coordinates and the momentum coordinates. So but here your Lagrangian is in terms of x dot and y dot. We have to express in terms of momentum p. So what is the thing that I have just mentioned is that find out the momentum, right? So px, here there are two coordinates, so px is equal to del L by del of x dot. I have just I did the example to you initially when I derived the Hamiltonians, right? It's equal to what? Now it will be equal to mx dot, isn't it? That means you differentiate del L by del of x dot. That means 2 and 2 will get cancelled. You have m of x dot. Okay, anyway the second term will be equal to 0 since there is no x dot term. Now py equal to del L divided by del of y dot. Simply here also you will get simply m y dot, right? Because the second term is equal to 0 anyway. Now x dot, remember that x dot is equal to px by m, right? And y dot is equal to py by m. Now you try to convert everything in terms of the momentum, not in terms of x and x dot. What we are express everything in terms of x and px or y and py. Okay. Now what do we need to do now is that you have got everything. You got the Lagrangian, which is the minus of u. You know the kinetic energy and you know the potential energy, and you have also expressed x dot in terms of px, y dot in terms of py. Now you need to write the Hamiltonian of the systems. Okay, using the equation h equal to x dot px plus y dot py, right, minus of Lagrangian. So what happens is that x dot, now you know what will happen is px by m, is it, into px plus y dot. Now you put the equation, we get py by m into py, isn't it? Then minus Lagrangian, anyway you already got from here. Let me name this as equation 2. Lagrangian is equal to half m. What is x dot square now? X dot square also you put with this in terms of px, so it will be equal to px square by m square, and y dot square also we get py square by m square, isn't it? And minus, but this minus term is here, so minus into minus you will get positive, plus it will become plus half k x square minus of y square. If you look at this equation now, your Hamiltonian is purely in terms of x and px or y and py, right? You see here x, you see here x in terms of px, y in terms of py and px. Okay, now since this equation you can still solve this equation a little more, because this will become px square by m plus py plus py square by m. Okay, minus half m. Again, this will be equal to m, and 1m from here and 1m from the denominator, that will get cancelled anyway. So I will just write the final equation. Okay, no need to do this. I will write directly equal to px square by 2m. That means you just subtract this and this, the first term and the second term, px square by 2m plus py square by 2m, and then anyway you have solved this equation, you get here plus half k of x square minus of y square. Sir, how the value of x dot and y dot come? Okay, so see, I think, okay, so let me just a question. So your kinetic energy is half of m of x, sorry, maybe a little confusion. Okay, half of m v square. Okay, take the example of your kinetic energy is simply half of mv square, correct? So what is velocity? Velocity is equal to dx by dt. Let's say if you are going in terms of let's say if you're considering only the x direction. Now what is dx by dt? Is v is equal to x dot. So I have just written here kinetic energy is equal to half of m of x dot square. But if you have two direction, that means the particle can move in the x direction as well in the y direction, then you have to add it up. We have here half m of vy square. So again, this is vx, so vy will also be equal to dy by dt. So velocity vy is equal to y dot. Okay, so I hope you understand what is x dot and y dot. It's just there. It's just from your kinetic energy term, half of mv square. So instead of velocity, we write in terms of your generalized coordinates. That's what we're saying. Generalized coordinate x dot and y dot. Okay, so remember now we never write in terms of velocity, momentum. We have written now in terms of the generalized coordinates. Okay, so now if you look at it, I hope it's clear to you. If you have any question, you can still ask me. Okay, so now you got what is the h of the systems, which is the Hamilton of the system. Now what is this? This is the first solution. Okay, if you look at the questions, the first question is write down the Hamilton of the systems. So if you want to write down the Hamilton of the system, you have to take this equation. And if you take this equation, anyway, you have to find out what is the Lagrangian. If Lagrangian is given to you, then well and good. Okay, you can just take directly the Lagrangian. And if Lagrangian, let's say this equation is already given to you, this Lagrangian here. Let's say this Lagrangian is already given to you, then you go ahead from this one. If Lagrangian is not given to you, then you have to find out what is a Lagrangian, which is in fact T minus kinetic energy minus your potential energy. If Lagrangian is there, then you solve directly from this from this steps, which is px, which is equal to del L by del of x dot. Or in general, I can say momentum is equal to del L by del qi dot. Qi dot can be x dot, y dot can be anything. Okay. So now the first equation is done. Now the second. What is the second? The second is we have to write the Hamilton's equation. Right, the Hamilton's equation. And Hamilton's equation, I have given it to be something like qi dot is equal to del h by del pi, and pi dot is equal to minus of del h by del qi. Okay, that I have given to you initially. Now, what are the things that comes into the picture here? We have what? We have now px, and you also have x term, you also have py, and you also have y term. Okay, there are 4 terms now. So first of all, let's solve their px first. Px dot will be equal to minus of del h divided by del, instead of qi will be simply x. Remember that this is my generalized coordinate. Qi, pi, these are the generalized coordinates. It's just a general variables. But now if we are solving in the x direction, then we have what? Px dot is equal to minus of del h by in terms of x. So what is del h by del x? In the first term and the second term, there is no x value. There is no x dependence. So you have only this term here, half of k of x square. So simply you will get what? Minus del h by del x. So only the second term will be there, which will be simply kx. Because 2 and 2 will get cancelled. Now, that is the first thing. Now, the second thing is what? X dot. if you look at the problems, okay, if you look at these Hamilton equation, there is qi dot and pi dot. So pi dot anyway we have written, pi dot is equal to minus of del h by del x. Now x dot is equal to what? Del h by del, instead of pi will be px, because we are working with the x. So now ph will be equal to what? If you look at this equation, there will be del h by, there is no px in the second term, there is no px in the third term, so only the first term will contribute. So we get twice px by 2m, which will be simply px by m. Okay, so now one part is done. Second part, what is second part? Second part is py dot, right, because there is also the x and y coordinates. So py dot will be equal to what? Del h by del py, sorry, minus of del h by del py, which will be equal to simply, anyway, again you have to differentiate, we will get simply k y, right, because this negative sign is there, so this negative sign in the Hamilton and the negative sign will get cancelled, so we get py dot is simply ky. And now what happens to y dot? Y dot is equal to del h by del py is equal to so y dot is equal to del h by del py, which is simply py by m, right? Again you have to differentiate this equation, del h by del py. So now you already have equation of motion, x dot, now y dot. Okay, this is what is called as your equation of motions, right, or Hamilton's equation. Now you have to solve this equation. This is x dot and this is y dot. Okay, you have to solve. So now what do we do here is that now the third point is we have to solve this equation. The third point is we have to solve this equation. Now what do we do is that we try to do this, let's say if we differentiate again, we get x double dot is equal to px dot by m. Why I'm doing this, you will see why I'm doing this. Why I take again I take again derivative. X double dot means okay, let me write this way, that will be clear. Let me write this way, d by dt of x dot is equal to d by dt of px by m. Start from here, again take the derivative, then you will get what? D by dt of x dot will be x double dot is equal to px dot by m. Okay, now the thing is that why I'm doing this is because you have to also consider this equation, right? There is a and there is b, so the idea is to equate both of these two equations. So now x double dot is equal to px dot you can take it from this one, equation A. So px dot is equal to minus of kx by m. So now from two equations you will get x double dot equal to minus of kx divided by m. Similarly here in the y direction also you can take y double dot equal to py dot by m, right? So y double dot will be equal to, what is py dot? Py dot again is ky, so we get ky by m. So if you look carefully here, y double dot equal to ky by m, and here you have x double dot plus k by m x equal to 0, and here you have y double dot minus of k by m y equal to 0, and here we get x double dot means d square x by dt square plus k by m x equal to 0, and y double dot means d square y by dt square minus of k dot by m y equal to 0. I think these two equations you have seen very, very often. Okay, even from, I think even in higher standards, I think you have seen this equation. This is in fact what? Simple harmonic motion plus omega square x equal to 0, isn't omega is equal to omega square is equal to k by m. I think you have seen quite often this equation, d square y by dt square minus of omega square y equal to 0. So this is simply, this is the solution is, I mean, if you want, you can use the this first order differential equation or second order differential equation, which is The solution of this is simply what? X equal to C1 e to the power of I omega t plus C2 e to the power of I omega t. That is the x coordinate, and in the y you will have what? Let's say you can write I can write b1 e to the power of omega t plus b2 e to the power of omega t. So how do we solve this problem? You use this equation. I think, okay, let me just write it here. Let me just give it to you. um, d square x by dt square plus omega square x equal to 0. So we can write something like d square plus omega square x equal to 0, right? And you solve d square plus omega square equal to 0. So d square is equal to minus of omega square. D will be equal to root over of minus of omega square, which is equal to I omega, right? Plus minus I omega, right? Then using from your differential equation, the solution of these problems will be y equal to c1 e to the power of I omega, let's say I omega t plus of c2 e to the power of I omega t. Okay, this is I have taken this from your normal differential equation mathematics. So if now you got from your main Hamiltonian equations, then you write the equation of motions, then finally you solve it. So this is your final solution. Okay, so now this is done. So if you look at it, we have solved problems from Newtonian mechanics, then we also have some solved problems from Lagrangian, then you also have solved problems from Hamilton, but all are pointed toward the same, to solve the equation of motion. Okay, all are the same, is just that the approach is different. Okay, so if you have any question, anyway, I will upload this notes in that folder, which I will be sharing with you, and also I will write a proper solution for each of your questions. Okay, now we will move to another part, which is relativity, and I have some 30 minutes to 40 minutes to finish. Okay, so let me just quickly there are two questions which I need to finish. Okay, so let me quickly let me quickly write again, before I solve the problems, I would like to write a little about something about this your STR, special theory of relativity, right? Let me just write a little about it, such that you will remember before I solve the problems. Okay, so I think you remember that there are, let's say there are two frame of reference. Okay, two frame of reference, x and s prime. Okay, s and s prime. And what happens is that now let's say that s prime is moving with a velocity v in the order in the x direction. Okay, in the x direction. Let's say this is your x, and let's say this is your y, and let's say this is your z. Similar, x prime, y prime, z prime, sorry, and this is x, and this is y, and this is z. Now suppose there are any particle here in the s prime frame. S prime frame means there are two locations from which you measure. Okay, is the position where you measure any events, I will say. So when I say frame of reference, is the point where you do the measurement, in that sense. Okay, so that means now there are 2 points. One is that, let's say one person is moving with a velocity v and try to measure something, and the other frame of reference means that one person is staying on the ground and also is trying to measure the same events, point P. Okay, let's say I will represent this as a point P. Okay, both person, let's say there are one person A here and one person B here. So the person B is staying on the ground and he also tried to measure any events represented by point B, and the position A here, okay, A is also moving with the velocity v, and also is trying to measure the same events point B. Okay, so what do we see? I'll just write quick Galilean transformation. So if Galilean transformation, what will happens is that, suppose let me draw some bigger, I think that will be better. So this is s, this is y, this is x, this is z, this is x prime, this is y prime, and this is z prime. Since this is moving with the velocity v, this frame, then what is the distance between this and this? is v into t, right? And let's say you have one point here, and this point is represented by x, y, z if you measure from the S frame, and x prime, y prime, z prime if you measure from this origin O prime, and if you measure. So if you measure from the S frame origin O, then you have x, y, z coordinates, and if you measure from your O prime, which is the origin, then you have x prime, y prime, z prime. Then what is, according to Galilean, what happens? X is equal to x prime even, but you have a term velocity into time because your S prime frame is moving with a velocity v. So this distance will be there, but your y will remain the same because there is no velocity in the y direction, and your z is also equal to z prime. Okay, but this Galilean transformation works well only when the speed of light, or when the velocity of, not when the speed of light, when the velocity is very less compared to the speed of light. But as you move very close to the speed of light, I will show you one thing why it cannot be done. It's because you have this, let's say you have one person on the ground. This is a person A is on the ground. Okay, remember person A is on the ground, and there is, let's say, a train is moving. Let's say a train is moving, and this train, let's say, is B, is moving with velocity v. Okay, now in the train, remember, in the train there is a light bulb. Okay, this light bulb is, velocity of the light is c, right? So now what happens, according to this relation, if you find the velocity, if you differentiate, this one will be equal to ux is equal to u of x prime plus v. Just differentiate dx by dt, you will get the velocity. Ux is equal to u of x prime. That means u of x prime is what? U of x prime is here, and u of x is the one measured by the point A, and ux prime is the velocity measured by B. So since this guy is holding, let's say, a light bulb, and it is there is a light which is moving by the velocity with the speed of light c, so you will get u of x prime is simply c, right? Because you are measuring from the, because the event is in the frame S prime, and let's say this is S. Okay, so there is a light inside the train, and this train is moving by the velocity v. So that means any events measuring by b will be simply c, the speed of the light. But if you use this relation, u of x will be equal to u of x prime plus the velocity of this train, then you instead get what? C plus your velocity of the train. This is not correct. This is not correct, because the speed of light has to be the same to be c. Cannot be c plus the velocity of v. It cannot be that way. So this is where your Galilean transformation, whatever I have written, x is equal to x prime plus vt, is not correct. Okay, I mean, it works only when the velocity is very less compared to the speed of light. But as you go to the velocity which is close to the speed of light, you cannot get this. Okay, so that is why comes your another transformation called Lorentz transformation. Okay, so I'll just write the Lorentz transformation because I will not have time because I have to solve the problem. So we get x is equal to x prime plus vt root over of 1 minus of v square by c square. Okay, y, let's say, is equal to y prime, z is equal to z prime, and t is equal to t prime plus v by c square x prime root over of 1 minus of v square by c square. Okay, this is inverse Lorentz transformation. The Lorentz transformation will be simply x prime is equal to x minus of vt. It's just in the negative direction. Okay, and in terms of velocity, what happens? We get u of x is equal to u of x prime plus v. Instead of u of x prime plus v, you will also have the term 1 plus v by c square u of x prime. Okay, and uy will be equal to uy prime gamma 1 plus v by c square u of x prime, and finally uz is equal to uz prime, uz is equal to uz prime 1 plus v by c square u of x prime. Gamma term is also there. Gamma term is in fact 1 by root over of 1 minus of v square by c square. Okay, so I think you have already seen this one. I will not discuss in detail, but let's solve the problems. Okay, but just remember that when you go from Gaussian transformation to Lorentz transformation, there is certain problems with the Gaussian transformation. That is why you introduce the Lorentz transformation. And this Lorentz transformation, at very, let's say if your ratio of your velocity to the speed of light tends to 0, then it will go back to your Gaussian transformation. Let's see if this term is very low, right? V by C is very low, close to 0, then you get x is equal to x prime plus v3, which is in fact what is your Gaussian transformation. Okay, so now let's solve first the problems. Okay, and also before solving problems, let me write again one more equation. Your length contraction is equal to L is equal to L naught, right, root over 1 minus of v square by c square, and your time dilation t is equal to t naught root over of 1 minus of v square by c square. Okay, L naught is actually what is the we call as a proper time, and T naught proper length. Why did I call it proper time? Is usually equal to proper length, and T naught is equal to proper time. Okay, so let's quickly solve the problems. Okay, so let's see solve this one first. Equation number 4, solution number 4. So solution is a pi meson with a proper time. Okay, proper time, let's say you are represent as T naught is equal to 2.5 into 10 to the power minus 8. Okay, decay into a mu1 and then neutrino. Okay, assuming that the pion has a kinetic energy, remember kinetic energy equal to the rest mass energy, what distance would the meson travel, okay, before decaying as seen by the observer at rest on the earth's surface? So remember that, now what happens that a pion is moving, okay, and it also is decaying into a mu1 and a neutrino. Now you need to find out what is the time in which the meson travel before decaying as seen by the observer at rest. Okay, so that means automatically there is S frame in which it mesh at rest, and there is also an S prime frame in which is just moving. So simply let's say pion, it decay into what? Mu1 plus neutrino. Now it's also given that your kinetic energy of pion is equal to your rest mass energy of mu1. Now before we solve these problems, I also give you the formula. E is equal to the total energy is equal to gamma of mc square. It's not simply E is equal to mc square. In relativistic you have mc square by root over of 1 minus of v square by c square. Okay, so now the total energy E of the pions will be equal to what? Will be equal to the kinetic energy of the pion plus the rest mass energy. Rest mass energy, the formula is m pi plus c square, that is the rest mass energy, is equal to what? Total energy is equal to m pi c square divided by root over of 1 minus of v square by c square. Isn't it? So I have just written the total energy which is equal to the kinetic energy plus the rest mass energy. But it is also given that your kinetic energy of pion is also equal to the rest mass energy, which is equal to m pi plus c square. Now your equation 1 will instead become what? Kinetic energy you can replace with m pi plus c square plus m pi plus c square is equal to m pi plus c square by root over of 1 minus of v square by c square. This is m pi plus. Right, so this will be equal to 2m pi plus c square is equal to m pi plus c square by root over of 1 minus of v square by c square. So this and this will be getting cancelled, right? M pi plus c square on the left and m pi plus c square on the right is weird. And 1 by root over of 1 minus of c square by c square is in fact gamma is equal to 2. So we will see why this is necessary. Okay, we will see why it's necessary. So from gamma, what happens then? You can write, gamma is equal to 1 by root over of 1 minus of v square by c square. So gamma square, if you square on both sides, will get 1 divided by 1 minus of v square by c square, and what happens? Gamma is given is measured from here to be 2, so 2 square will be 4 is equal to 1 minus of v square by c square. So you can find the velocity from here. Okay, carry this one, we'll get something like 4 c square minus of 4 v square equal to c square, and we get velocity is equal to root 3 divided by 2c. So from the total energy, you can calculate what is your value of gamma term, and you can also calculate what is your velocity term. Now, see, there are two things here. Now there are two things. It is given in terms of the proper time, 2.5 into 10 to the power minus 8. That is in the frame of reference. But what you measure is not the proper time, because this is also moving, right? So now what happens is that you have to find out the time which you measure, not the proper time. Okay, it is given in terms of the proper time, but you have what you measure is not the proper time. So the time, okay, the lifetime, I would rather say the lifetime, okay, of pi meson as seen by the observer is what? Is your time dilation, which is actually t is equal to t naught root over of 1 minus of v square by c square, which is equal to 1 divided by root over of 1 minus of v square by c square is equal to gamma t naught, right? So gamma you have already calculated to be 2 into your t naught is given to be 2.5 into 10 to the power minus of 8. So you can put it here, 2 into 2.5 into 10 to the power minus of 8, you can get to be something like 5 into 10 to the power minus of 8. And this is in terms of seconds. Okay, now you know the time, then you can easily calculate it, because now you know the time in which you measure, okay, from your frame of reference, which is at rest. Then you can easily calculate what is your distance, because that is the question. The question is calculate the distance, or what is the distance will the mason travel before decaying as seen by the observer. So you have to calculate the distance. Now you already know the time in which you measure, not in the proper time. You are already measured the time dilation, in which it is given by t is equal to t naught by root over of 1 minus of v square by c square. So you can easily calculate the distance, which will be equal to v into t. Distance is equal to velocity in time. So what is the velocity? Velocity you have already calculated here, root 3 by 2c, right, into what is the time? Time you can get here, 5 into 10 to the power 8. Okay, and what is the distance? Distance is equal to root 3 by 2. C is 3 into 10 to the power 8 meter per second into 5 into 10 to the power 8. Okay, so 10 to the power 8 and 10 to the power 8 will get cancelled. So we'll get 15 root 3 by 2 meter. So this is the distance. So what did you solve here? You first solve the time in which you observe. Then you use the formula distance is equal to velocity into time. So you use the time dilation formula. And why do you need the time dilation formula? Because you need to calculate the distance. And in this case, to calculate the time, you also need 1 minus of v square by c square. Right? You need this equation 1 minus of v square by c square. That is why you calculated value of gamma. Okay, so remember that why you need gamma. You need gamma because you need to put in the equation t is equal to t naught by root over of 1 minus v square by c square. And why do you need velocity? Again, you need the velocity because you need to calculate the distance. That is why you solve the value of gamma. You solve the value of gamma, and you solve the value of your velocity. Okay, so I think this is clear. Then there is a last problem. Okay, there is a last problem. There is a last problem, and this problem is relative to your whatever I have given to you. U of x is equal to u of x prime plus v 1 plus v by c square u of x prime. Okay, so that let me just explain to you this. This is the final things. Okay, final questions, and then we will stop. Okay, so now again let's look at this problem. Okay, let's look at this problem. Remember that there are always two let's say two frame of reference. One is, let's say it has a rest and the other is moving. He himself is moving and he tried to measure some events. Okay, so here also a bus of length L move at a speed 5c by 30. So there is a bus of length L. This is a bus of length L and this is moving with 5c by 30 with respect to the ground. So there is a ground here. Okay, so this bus is moving at a speed 5c13 with respect to the ground. Okay, so that means you can consider this one as a S prime frame because it's moving, and you can consider ground as your S frame. Inside the bus, a ball with respect to the bus is c by 3, which means that inside the bus a ball what is okay I think there is some confusion in this question. Inside the bus, a ball with respect to the bus is c by 3. That means, okay, so that means inside the bus, okay, a ball is thrown with c by 3 velocity with respect to this one. Okay, not with the ground. So remember, now there is a particle, there is another frame. You call it as a particle frame. For example, you call it as P frame, you call it an S prime frame, and you call it as S frame. Okay, and this ball is measured from what? From your S prime frame. Okay, not from S frame. Remember that the ball is inside the bus, is thrown with a velocity c by 3. Now as viewed by someone to the ground, that means now you try to measure from here. How much time does the ball spend in the air and how far does it travel? Okay, that means how much time does the ball stays in the air and how much far is traveled. With not measure from your S prime. S prime is anyway, for him is stationary. Okay, a particle with respect to the S prime frame is because both of them are moving, so there's no problem. But what happens, you see from the S frame. Okay, now, so let's see velocity of the ball. Okay, I'll solve now. Velocity of the ball with respect to the velocity of the ball with respect to the bus. Okay, that is given to what? C by 3. C by 3. Okay, now velocity of the bus with respect to the ground is given to be 5c by 30. Right, this is what is given to us if you look carefully. Now, but what you need to find? You need to find what is the velocity of the ball with respect to the ground. Right, this is what you need to find. This is what you need to find. Okay, as observed by the observer. So anyway, the ball with respect to the bus is given, bus with respect to the ground is given. So you can treat this one what? You can treat this one as u of x solution. U of x is equal to u of x prime plus velocity v 1 plus v by c square u of x prime. This I have just write the formula. So what is u of x prime? U x prime is what is this measured from the S prime frame. What is measured from the S prime frame is this one, isn't it? So this will be u of x prime frame because it's measured from the bus. So it will be equal to c by 3 plus what is the velocity of v? Now the velocity of the bus with respect to the ground will be the velocity v. So we get 5c by 30. Right, because the bus is measured from the ground now. So this velocity is what? Velocity from the very beginning. V is the velocity that is measured from the ground, whereas u of x prime is the velocity of any events which is measured from the S prime frame. So now what happens? You get 1 plus again 5c by 13 divided by c square into u of x prime will be c by 3. Right. So now what happens is that you can take you can solve this equation. So c and c square, all of this will get cancelled. Finally, you will get something like c by 3 plus 5c by 13 and then 1 plus again what happens is that 13 is there, so will be equal to 5 by 39. Okay, and if you solve this velocity, you will get something like 13c plus 15c by 39, and again you will get some 39 plus 5 divided by 39, you will get 7 by 11c. Now what does it means? It means that now you have solved u of x, which is the velocity of the ball, okay, as measured from the ground. This is u of x, this is v. Okay, so now you have been now you have measured whatever the events from your frame of reference or from the observer address. Now this is easy now. Okay, because you have already know the velocity, and you can just need to calculate what is the time and what is the distance. Okay, so we will try to use one trick here. I feel like one trick is good to understand. So first, look at this look at proper this equation. Delta t is the time that you need to find out. Okay, it's the time that you need to find out of the events of the ball measured from your frame of reference, that is from the frame address or from the observer address as given here. As viewed by someone on the ground, how much time does the ball spend in it, and how far does it travel? So delta t is the time that you have to find. Let's say delta t into 7 by 11c, this velocity. What do you get delta t into? You will get the distance, right? T into the velocity, you will get the distance. And this distance is equal to what? If you look carefully, this distance that you measure is equal to what? First of all, when the bus of length L is moving such a high speed of 5c by 13, what will happen? There will be a length contraction, right? So there will be length contraction. So you have first is the length contraction of the bus L, and root over of 1 minus of velocity v square by c square, but v will be equal to 5c by 13 whole square by c square. This is the velocity of the bus with respect to the ground. Okay, remember, or with respect to the observer address. Now, so there will be a length contraction of the bus plus, and also the ball is moving with velocity what? 5c by 13 delta t, because also the bus is moving with 5c by 13 delta t. So if you look at it, the distance is in fact what? Is in fact, first of all, there will be a length contraction because it's moving so fast, and also it is moving with the velocity 5c by 13. Okay, so now you can carry this delta t. So we get delta t is equal to 7 by 11 minus of 5 divided by 13 c equal to L, and root over 1 minus of, then will be 25 by 169. Okay, and delta t will be equal to, and if you take the LCM of it, you will get something like 143 and 91 minus 55. Okay, c is equal to L, and this is equal to 169 minus 25 but by 169. And finally, if you take this delta t and take the difference of it, you will get 11 by L by c. Now you get what is the time in which the ball as you measure is equal to 11L by 3c. This is the time. Okay, and how do you get the time? Is in fact you use this equation. Okay, this is equation in which you can use, okay, that is the time into the velocity that the ball is that the ball is moving with respect to you, is in fact what? Is in fact the length contraction, because there will be a length contraction of the bus, plus how far the bus is moving with the velocity, what the bus is velocity with 5c by 13. Okay, now then you know the 11 L by 3c, then you can easily calculate what is the length. Now you know the length, you know the time, you can easily calculate the length, which is equal to velocity into your delta t. So velocity is what? Velocity is calculated to be 7 by 11c, right? So 7 by 11c into the time is given by 11L by c. So it will be c and c will be get cancelled, and 11 will get cancelled. We get 7 by 3. Oh, sorry. So this is 7. This is sorry. Let me just cancel. Now you have the velocity. The velocity is in fact given to you to be 7 by 11, right? 7c by 11, that is 7c by 11 into the time t is 11 by 3L. Right? So 11 and 11 will get cancelled. You will get 7 by 3L. So this is your length. And remember, this L here is not the same as the length here. Okay, this L here is the length, proper length of the bus. Remember, I have given you L naught, but in this problem is given as L. That means it's the proper length of that bus. But what you measure is not the same length because it's moving such a very high velocity of what? Of given length 5c by 13. That is why you will not be measured the same length. You will be measured with a different length. Okay, and this different length is given by this equation. L is equal to this equation here. L is in fact L is equal to L naught 1 minus of v square by c square. But since the proper length is given to be L, so I can write here something like L prime is no, not L prime. It will be confusing. I can write maybe some L1, which is L root over of 1 minus of v square by c square. And this velocity by c is in fact 5c by 13. Okay, so all the 5 problems I have solved. Okay, and I will upload also this one in the drive as suggested to me by the organizers. So if you have any questions, you can always ask me through mail. Okay, you can ask me through mail. I'll just give you a mail, my mail ID here. You can take my mail ID lucky22@iisertvm.ac.in. Okay, you can mail here, or you can ask any questions, okay, if anything. And if there is any questions which you would like to add, we can take it in the next session, that is next week, okay, or even at the at the end of your course also there will be a supplementary the classes which we will be discussing any remaining other problems. Okay, so if you have any questions, you can ask, otherwise we can wrap it up here. So I think there is no questions. So if that is the case, then I have 10 minutes more. Okay, 10 minutes more ideally. And before I leave, let me just properly because I have just rushed a little, so let me just give you a little of for 1 or 2 minutes about the proper length and the proper time, because I couldn't get to discuss properly why do we use proper length and proper time, that is L naught and T naught, right? What is proper length and what is proper time? Okay, so proper length is in fact the length measured in which there is no relative motion between let's say a rod and the observer. Okay, what I mean by this is that, let's say you have your S frame here and you have the S prime frame here, and this S prime here is moving at velocity v. So but if you have a rod here, let's say this is the boss and this boss is moving at velocity, and you put and you put a rod inside the boss. So suppose if you are here, let's say you are here and you measure this the length of the rod, it will be the same, it will be always L naught, because there is no relative motion between you and the rod. Okay, whatever you measure is the same L naught. But for this guy sitting here, he will see what, since this is very velocity is very high, he will see with L is equal to L naught 1 minus of v square by c square. If you are here in the S prime frame, you will get the proper length because there is no relative motion between you and the rod. Okay, it's always L naught. But for somebody here, let's say this is a point A, and for the person in point B, what will happen is that he will see that there is a length contraction with given the formula L is equal to L naught root over of 1 minus of v square by c square. Okay, similarly for the T is equal to, also the proper time is also T is equal to T naught divided by root over of 1 minus of v square by c square. It also means the same. Suppose the events occurs, suppose I will write it here. Suppose there is the S frame and there is the S prime frame. Okay, so and this prime S prime is moving at velocity v, and there is events occurring here, and this events, whatever the events, and you are here, and whatever the events that is occurring here inside, let's say this is the bus which is moving at a velocity v, whatever the events occurring here and what events with you, they are the same. Whatever the, whatever the events that you measure will be T naught. There is no difference because you are at rest, because you and the bus are moving, right? You and the bus are moving with the velocity v. You are inside the bus moving velocity. So whatever events that you measure will be always equal to T naught. But for this guy here staying here, he is at rest and he is seeing that the bus is moving. That is why he will see not the proper time, but in fact the time dilation, which is T is equal to T naught by root over of 1 minus v square by c square. Okay, so proper length or proper time is the let's say proper length is the length in which you measure and there is no relative motion between you and the object that you measure. But if that object is moving and you try to measure, then you will not get the proper length, but you will get what is called as a length contraction. L is equal to L naught root over of 1 minus v square by c square. And similarly for the time dilation also, if you are measuring any events in such a way that there is no relative motion between you and the object, then in that case you will have a proper time. But if that object is moving or if that event is moving and you try to measure others, you will get what is called as a time dilation, which is given by T is equal to T naught by root over of 1 minus v square by c square. Okay, so I think thank you so much for attending the classes. Okay, so any necessary questions if you have, you can always send me through mail. Okay, I hope you understand and thank you so much. Yeah, thank you.